The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to go on and cover section 8.5, solving absolute value equations. So let's start out with a little bit of a review of how absolute value works. Okay, let's say we've got the following number line, okay? The distance from 7 to 0 on the number line would be 7 units. The distance from -7 to 0 on the number line is also 7 units. The absolute value of a number is the distance from that number to 0. Absolute value is determined or indicated by two vertical bars surrounding a number. So the absolute value of 7 would be 7. The absolute value of -7 is also 7. The distance from that number to 0 on the number line. Absolute value is positive, never negative, positive with one exception. The absolute value of 0 is 0 because the distance from 0 to 0 is 0. But other than that, it's always given as a positive number. All right, now, so since the absolute value of -7 equals 7 and the absolute value of 7 equals 7, suppose we had the following equation. The absolute value of x equals 7. All right, well, if x was 7, the absolute value of 7 would be 7. Or if x was -7, the absolute value of -7 would be 7. So we get two possible equations with two possible solutions. We get what's inside equals what's outside, or what's inside equals the opposite of what's outside. Let's carry that further. So let's say we've got the absolute value of x equals 12. Well, then we'd have x equals 12, or x could equal -12, or the opposite of 12. Both of those values of x, taking their absolute value, we would get 12. Let's extend that further. Let's say we had the absolute value of x plus 3 equals 15, okay? So the quantity inside would have to either equal 15 or it would equal the opposite of 15. If x plus 3 is 15, the absolute value of 15 is 15. If x plus 3 equals -15, the absolute value of -15 is 15. But now we can go further and solve each of these equations for just x. The first equation, subtracting 3 from both sides, we get x equals 12. The second equation, subtracting 3 from both sides, we get x equals -18. Let's check both of those solutions. If x is 12, we'd have the absolute value of 12 plus 3 equals 15. Well, 12 plus 3 is 15, so now we've got the absolute value of 15 equals 15. And since the absolute value of 15 is 15, we end up with 15 equals 15, so x equals 12 is a valid solution. How about x equals -18? Well, plugging that in, we'd get the absolute value of -18 plus 3 equals 15, but -18 plus 3 is -15, and the absolute value of -15 is 15. So once again, we get 15 equals 15, and the second solution checks. So this absolute value equation has two solutions. All right, what's inside equals what's outside. What's inside equals the opposite of what's outside. Let's say we've got the absolute value of 2x minus 6 equals 14. So we've got 2x minus 6 equals 14, or 2x minus 6 equals the opposite of 14, or -14. Again, we get both, or rather two equations. Solving the first equation, we'll add 6 to both sides, giving us 2x equals 20. Divide both sides by 2, giving us x equals 10. The second equation, adding 6 to both sides, we get 2x equals -8. Divide both sides by 2, and we get x equals -4. Let's check the two solutions. If x is 10, we'd have the absolute value of 2 times 10 minus 6 equals 14. 2 times 10 is 20. 20 minus 6 is 14. The absolute value of 14 is 14, so 14 equals 14, and it checks. If x is -4, we'd have the absolute value of 2 times -4 minus 6 equals 14. 2 times -4 is -8. -8 minus 6 is -14. The absolute value of -14 is 14. 14 equals 14, so the second solution also checks. All right, let's say we've got this situation. We've got an absolute value equal to 0. So what's inside would have to equal 0, or what's inside would equal the opposite of 0. However, the opposite of 0 is just 0, so we really have the same equation twice. So we only need to deal with one situation. Subtracting 12 from both sides, we get x equals -12. Checking our work, the absolute value of -12 plus 12 equals 0. -12 plus 12 is 0. The absolute value of 0 is 0. 0 equals 0, so we get one solution. So again, if we have an absolute value set equal to 0, it just produces one unique equation with one potential solution. Let's say we have a situation where there is an absolute value equal to a negative number. Well, if you think about it, a little while ago I said that an absolute value is always positive unless you take the absolute value of 0, in which you get 0. So an absolute value can't be negative, so we can't get a solution to this. But we can go ahead and ignore that and solve it and come up with extraneous solutions. And then when we check them, we'll see that they don't work. So let's go through that process. Well, x plus 4 could equal -6, or x plus 4 could equal the opposite of -6. If x plus 4 equals 6, subtracting 4 from both sides, we get x equals -10. If x plus 4 equals the opposite of -6, that's like x plus 4 equals, well, the opposite of -6 is +6. Subtracting 4 from both sides, we get x equals 2. So let's check these two solutions. If x is -10, we get the absolute value of -10 plus 4 equals -6. -10 plus 4 is -6. The absolute value of -6 equals -6. The problem is the absolute value of -6 equals +6, so that doesn't work. If x is 2, we get the absolute value of 2 plus 4 equals -6. 2 plus 4 is 6. The absolute value of 6 equals -6. Oh, but the absolute value of 6 is 6. 6 doesn't equal -6. How about -6? So there's no solution, okay? These two potential solutions, they don't work. All right. So now let's talk about something that I didn't mention before. Let's say we've got x plus 3 inside, and then -5 equals 12. All right. Before you produce the potential solutions or the potential equations without the absolute value bars, you always want to isolate the absolute value term first. On all these other examples, it was just a single absolute value, okay? So now, or set equal to something else. So now I've got more than one term on the left side of the equation. The first thing I need to do is isolate the single absolute value term. So I'm going to add 5 to both sides of the equation, giving me the absolute value of x plus 3 equals 17. Now that I've isolated that absolute value term, I can go back and say, well, x plus 3 equals 17, or x plus 3 could equal the opposite of 17, or negative 17. Solving each equation, the first equation, I'll subtract 3 from both sides. X is 14. The second equation, subtract 3 from both sides. X is negative 20. Let's check our work. Let's take x equals 14 and plug that into the original equation. The absolute value of 14 plus 3, outside the absolute value, minus 5 equals 12. 14 plus 3 is 17. The absolute value of 17 is 17, and 17 minus 5 is 12, so 12 equals 12. X equals 14 checks as a solution. Let's try x equals negative 20. So we get the absolute value of negative 20 plus 3 minus 5 equals 12. Negative 20 plus 3 is negative 17. The absolute value of negative 17 is 17. 17 minus 5 is 12. 12 equals 12. So both solutions check. But again, it's super important that you isolate the absolute value term before you split things apart. Otherwise, it's not good. Okay, now let's say we've got something like this. 2 times the quantity x plus 5 minus 16 equals 42. Okay, so again, I want to isolate the absolute value term completely before doing anything else. So my first move is going to be to add 16 to both sides of the equation. Let's see, that's going to be 58. My next move, I'm not going to distribute the 2 inside the absolute value bars from the outside. I'm going to divide both sides by 2. Let's see, what's half of 58? That would be 29, I think. So now I've got an absolute value isolated equals a number. So I get x plus 5 equals 29, or x plus 5 equals the opposite of 29, or negative 29. Solving the first equation, we'll subtract 5 from both sides, and we get x equals 24. Solving the second equation, subtract 5 from both sides, and we get x equals negative 34. All right, here, let's see. I've run out of room to check my work. So what I'm going to do is I'm going to recopy the original problem on the next page. 2 times the absolute value of x plus 5 minus 16 equals 42. And then I've got x is 24 and x is negative 34 is my 2 possible solutions. Okay, so if x is 24, we get 2 times the quantity, the absolute value of 24 plus 5, minus 16 equals 42, which would be 2 times the absolute value of the quantity, 29, minus 16 is 42. But the absolute value of 29 is 29, so I get 2 times 29 minus 16 is 42. 2 times 29 is 58. 58 minus 16 equals 42, and 58 minus 16 equals 42, so 42 equals 42, so x equals 24 is a correct solution. Now let's go back and check x equals negative 34. 2 times the absolute value of negative 34 plus 5, minus 16 equals 42. Negative 34 plus 5 is negative 29. The absolute value of negative 29 is positive 29. So 58 minus 16, 42 equals 42, and it checks. Again, the solution is not 42. The solutions are 24 and negative 34. But when I plug them in, I get a true statement at the bottom of the process. All right, now, Another situation is where you've got an equation that has two absolute value terms in it. Let's see here. If you have an equation with just two terms and they're both absolute value terms, you want to separate them, have one on each side of the equation, which is what I've got right now. If you get a situation with two absolute value terms and yet another term, that's beyond the scope of what we're going to look at right here, okay? But if I've got two absolute value terms, I want one on each side of the equation. Now, let's look at the possibilities here. We could take what's inside of the first one equals to what's inside of the second one. We could take the opposite of what's inside of the first one equal the opposite of what's inside the second one. We could take what's inside of the first one equals the opposite of what's inside the second one, or we could take the opposite of the first one equals what's inside the second one. These are all possibilities, okay? Just like, for instance, the absolute value of -7 equals the absolute value of 7. The absolute value of -7 equals the absolute value of -7. You get the absolute value of 7 equals the absolute value of -7. Anyway, you get all these different possibilities, okay? But if we examine this further, we notice if we take this first equation and multiply both sides by -1, we actually get the second equation. So those are redundant. If we take the second equation and multiply both sides by -1, we get this on the left, and negative times negative is positive. We get that on the right. So that's redundant as well. So basically, we've only got two potential equations produced from that. So we've got this equals, let's see, is it 3x minus 21? So let's take what's inside the first equals what's inside the second, or what's inside the first equals the opposite of what's inside the second, okay? That will give me the two different possible equations. So in the first equation, solving, I'm going to subtract 3x from both sides, giving me x minus 7 equals -21. And I'll add 7 to both sides, x equals -14. In the second equation, I get 4x minus 7 equals, I'll distribute and get -3x plus 21. Adding 3x to both sides, I get 7x minus 7 equals 21. Add 7 to both sides, 7x equals 28. Divide both sides by 7, x equals 4. Well, let's check those two solutions. If x is -14, we get the absolute value of 4 times -14 minus 7 equals the absolute value of 3 times -14 minus 21. 4 times -14 is -56. -56 minus 7 is -63. And the absolute value of -63 is +63. On the right side of the equation, 3 times -14 is -42, and -42 minus 21 is -63, and the absolute value of -63 is 63, so it checks. Okay, I've run out of room here to check my work, so I'm going to go back and erase some of this so that I can check my solution without having to go to the next screen. If x is 4, the absolute value of 4 times 4 minus 7 equals the absolute value of 3 times 4 minus 21. 4 times 4 is 16. 16 minus 7 is 9. The absolute value of 9 is 9. 3 times 4 is 12. 12 minus 21 is -9, and the absolute value of -9 is 9, so it checks. So x is -14, x is 4. All right, so let's review this. If you have an equation with two terms, both of which are absolute values, you want to separate them, one on each side of the equation, and then you come up with two possible equations. What's inside of one equals what's inside of the other, or what's inside of one equals the opposite of what's inside of the other. If you have an equation with one absolute value, before you do anything else, you want to isolate that absolute value. Get rid of anything outside of it. Put it all over on the other side of the equation. And then you get two possible equations. What's inside equals what's outside. What's inside equals the opposite of what's outside. If you have an equation set equal to 0, an absolute value equation set equal to 0, where it's just the absolute value equals 0, you're going to get just one unique equation. So you'd want to solve that. If you have an equation where a single absolute value is set equal to a negative number, you're going to come up with potential solutions, but they aren't going to work. Okay, well, that's all I have for today. And so I will be back this afternoon at 1:15 with an office hour if you have any questions. Just a reminder, if you do have questions for me and you want to reach me, use email. Don't send messages through Canvas or through WebAssign, only through my school email. All right, well, have a great rest of the day, and we'll see you tomorrow.